Section 1.1 is measurements and estimates. In the IB program, you do a lot of data collection and analyzation of that data, and that's a skill that we want to develop for your college and career. So one of that is learning how to take measurements specifically. Obviously, measurements help us compare and relate objects, the size of things, the weight of things, whatever specifically that you're trying to measure. It does rely on some sort of approximation depending on what unit you're using. The smaller the unit, the more accurate. So for example, a centimeter measuring to the nearest centimeter would be more accurate than measuring to the nearest inch. But measuring to the nearest millimeter would be more accurate than measuring to the nearest centimeter. So that's where a little bit of approximation comes into play. So when you're going to measure something, obviously the first thing is, what are you even measuring? Are you measuring the weight, the height, the length, the volume, the density? Choosing the appropriate tool. So for example, if you are measuring length, are you going to use a ruler? Are you going to use a tape measure? Are you going to use a laser? And those also will affect your accuracy and your approximation. Obviously, what unit are you going to use? In this class, we're almost exclusively going to be using the metric system because it's international. But if you're doing something that is only pertaining to the US, maybe you choose to use imperial units. And then obviously doing the measurement and determining the number of units based on your level of accuracy. In addition to that is estimation, so approximating as close to the value of measurement by some kind of sensible guessing. So whether that be comparing it to something that you already know the length of, for example, if you know, oh, I have a ruler here and I know that's 12 inches, that's 1 foot, and then kind of, looking at that compared to whatever you're trying to measure and getting a accurate, as close to accurate as possible measurement or estimation. Another tool for estimation is sampling, which is something we're going to be talking about in a few weeks. So maybe you're trying to make measurements of, a huge population, and so you measure part of that population, a sample of that population, and then you extrapolate that data to make statements about the population as a whole. Section 1.2 is recording measurements, significant figures, and rounding. So once you've actually taken your measurements, now we need to record them and write them down. And that will also play a part in the accuracy of your measurements by how you write them. So one way that we do that is by significant figures, which you guys talk about in your science classes. So only those digits that are definitely known plus one estimated digit. Measuring instruments are only able to determine a certain number of digits depending on their scale. For example, if the ruler that you have measures to the nearest centimeter, that's going to be different than to the nearest millimeter. And then how many, partial centimeters or partial millimeters do they show? So in this class, unless it's otherwise noted, you always need to round your answers to 3 significant figures. Again, unless they tell you otherwise in the problem or in context. So for the rules for significant figures, you have, first one, anything that is not a 0 is considered significant. Zeros that are in between non-zeros are considered significant. So for example, if you have 202, then the 0 that is in between, that is significant. Leading zeros are never significant. So if you have something like this, then all of these zeros here are not significant. Trailing zeros after a decimal point are significant. So if you have a decimal point and then you have some zeros afterwards, those are significant. If you have trailing zeros without a decimal place, so for example, the number 200, these zeros are not significant. So I would make sure you have all of those written down. And then again, for IB, your answers need to be at least 3 significant figures unless it says otherwise. You can leave them exact, so exactly how your calculator writes it, or in, for example, in terms of pi or something. But if you are going to round, the fewest you can have is 3 significant figures. So here are some examples. Let's start with number 1. So for each of these, A through D, I want you to determine the number of significant figures. So go ahead and pause the video and find the number of significant figures in number 1 through A through D. So I've done A and B. So for A, every single number, 21.36, everything is non-zero, so therefore everything is significant, so there would be 4 significant figures. For B, 305, the 0 is in between 2 non-zeros, so therefore every single one of these digits is significant, so there are 3 significant figures. So if you haven't already done so, go ahead and pause the video and do C and D. For C, trailing zeros with a decimal point are significant, but leading zeros are never significant. So the first significant digit is 3, and then both of the zeros after that, so there are 3 significant figures. For D, leading zeros are never significant, and there's no trailing zeros, so the only significant figure is this 2, so there's 1 significant figure. So now we want to round to significant figures, so we have this number 0.1235, and we want to round that to 2 significant figures. And then 415.25, we want to round that to 3 significant figures. So remember, when you're rounding, you find the place that you want to round to, and then the number after that, if it is a 5 or bigger, you round up. If it is a 4 or smaller, you round down. So go ahead and pause the video and round A and B to the given number of significant figures. So for A, we want to round to 2 significant figures, so the 1 and the 2 I want to have there. So I'm rounding this 2 based on the 3. 3 is 4 or smaller, so I'm going to round down. So I end up with 0.12. The 0 doesn't count, it's not significant because it's a leading 0. And then for B, we want to round to 3 significant figures, so the 4, 1, 5, we want to make sure those are intact. So we're looking at the 2 to round the 5. 2 is less than 4 or less, so therefore we round down, and so it's just 415. Lastly, number 3, we have a circle that has a radius of 12.4 centimeters, and we want to find the circumference to 3 significant figures and then to 1 significant figure. And then we also want to find the area, leaving it exact, and then rounding that to 1 significant figure. So go ahead and pause the video and find the circumference and the area of a circle that has a radius of 12.4 centimeters. So for the circumference of a circle is 2 pi r, where the radius is 12.4. So the exact answer is 24.8 pi. I plugged that in my calculator and I found that 77.91149 to more than 3 significant figures. And then I took this and rounded it to 3 significant figures. So 1, 2, 3. The 1 rounds the 9 down, so 77.9 centimeters. When you're answering IB questions, they want 3 significant figures, but exact or more than 3 significant figures is good. It's always good to write that first. That way, if you round wrong, you can still have the correct answer up here. And then part AI wants you to round to 1 significant figure. So I took this 77.9. I'm going to round to the tens place in this case. So it's a 7, so I'm going to round this 7 up, so it becomes 80 centimeters. Which one's more accurate? Obviously, the more significant figures, the more accurate. So 77.9 is much more accurate than 80. 24.8 pi would actually be the most exact, but for the 3 significant figures is always going to be more accurate than the 1 significant figure. So if you haven't already done so, go ahead and pause the video and do the same thing for the area. So for the area of a circle, you have pi r squared, where in this case the radius is 12.4. So the exact value would be 153.76 pi. I rounded that to 3 significant figures to kind of follow the same directions as part A. And so that would be 483 centimeters squared. And then part A, BI wants us to round to 1 significant figure. So we're going to look at the 4, the hundreds place, the 8's going to round it up. So we end up with 500 squared centimeters. So of course, again, same thing, 483 is going to be more exact than 500. 153.76 pi is going to be the most exact. So exact, leaving things in terms of pi, in terms of square roots, is always going to be more accurate, but the more significant figures is always going to be more accurate than less significant figures. So this has been measurements and rounding and significant figures.